All right. Good day, everyone, and welcome back to my calculus class. So today I'm going to be studying application of derivatives, and first of all, I'm going to be looking at derivatives as rate of change. So let us briefly look at motion along the line. The charts I put here just represent what happens when you drive, when you are speeding and you are accelerating, or you are reversing, you are accelerating or you are decelerating. That is, you are pressing your gas or you are pressing the brake. Or you are driving, you're moving forward and you get a stop sign, red light, you stop momentarily, then you keep moving. So I just use these signs to represent those situations. But there are a couple of things I want you to bear in mind. So when the velocity and the acceleration have the same sign, then it means you are speeding up. When they have opposite sides, it means you are slowing down. So please take note of that. When your velocity is zero, that is you are not speeding, and the acceleration is positive, it means you are about to speed up. Um, the same thing, if it is zero and your acceleration is negative, it means you're about to speed up as well, but then um you are at rest, about to move left, want to move left. So let me see. Okay, this happens to us a lot. Our velocity is not zero, that is, you are moving, but your acceleration is zero. You are neither using brake nor your leg is on gas. So that means you have constant speed and you don't have any acceleration. If there is no speed, no acceleration, then it means you are completely at rest. So there is nothing fancy here. Just know that when the signs are the same for velocity and acceleration, it means you're speeding up. And when the signs are, you know, opposing, opposite, it means you are slowing down. So that is the major point here. And in terms of calculus, suppose you are given a function that represents your position, the position of the object. It could be car, it could be a body moving. So now if you take the derivative, that is the rate of change of that position, that will be the velocity. Then if you find the rate of change of your velocity, then you have acceleration. And then there are other higher levels. If you take the derivative of your acceleration, that is the rate of change of acceleration, you have what we call jerk. That happens when you are driving and you just press the brake, or suddenly what you experience is a jerk. Or maybe you are moving, then you just press your gas, suddenly you just accelerate like all of a sudden. So you experience it, your body will feel it. There is other higher level called snap. We just, leave that. That is the rate of change of jack. So I will now consider that in this study. So like I've said, the rate of change of position is velocity. That is when you differentiate your position, you get velocity. Now, velocity would have magnitude and direction. So if I have -3 for velocity, it is telling a story that it is going in the negative direction, but the magnitude, the speed itself is 3. We cannot have negative speed. So, but That negative is telling the direction, talking about the direction. So to talk about the speed, we need to take the absolute value of the velocity. And acceleration is the rate of change of your velocity, like I've explained earlier. So second derivative of your position function. Let us take example. To begin with, I want to compare instantaneous velocity and average velocity. Let me start. If I ask you, let's say this is the graph that represents my journey from, uh, let me do this, my journey from this point. That is not what I want. So let's say I'm moving from point A to point B. And let's say this is maybe 5 minutes for me to get there. And I ask you, what is the average velocity? So this is time, and this is time. This is what's it called? Distance. Distance covered. Distance covered. If I ask you what is the average speed, so you would say, well, you know what to do. You just need to ask what is S at this point, 5, minus S at the starting point, 0, divided by 5 minus 0. We know that, average. But remember, we also consider instantaneous at an instant of time. So that is when we introduce this concept, say when your time is A. So we say you can denote it using this, the limits as, let's say, h goes to 0 of f of a plus h minus f of a divided by h. So we call this the instantaneous rate of change. We have learned this. Now, how does this help us to solve this problem? Let us compare the two. Now, the question here is, what is the instantaneous velocity of the ball when it hits the ground? So you drop a ball. When the first question is, when does it hit the ground? We need to know the time. We're not given the time. So there is something here that will tell us when it hits the ground. Remember, I'm giving height. So that means the height of that ball is 0. So meaning I can ask, when is the height 0? So meaning I can say negative 16t squared plus 64 equals to 0. So negative 16t squared equals to negative 64. T squared equals to 64 over 16. Negative cancel negative, and that is 4. And t is plus or minus 2 seconds. But we cannot have negative times, so t equals to 2 seconds. So it takes 2 seconds to move from here to get that. Okay, now let us find our instantaneous velocity. Remember, to find instantaneous velocity, it is the same thing as taking derivative of s. So which is negative 16 times 2, that is 32t. Yeah, differentiating this. So negative 32t. Now at that instant of time, so that is v of 2 when it hits the ground. So v of 2 is negative 32 times 2. So which is negative 64 feet per second. That is the unit. Remember, distance over time. So feet over time, seconds. So, all right. Now, what about the average velocity? Well, like we did the other time, average velocity, let me do it here. So this is a B, average velocity. Average velocity. What does that mean? That is the average speed over the entire journey. So that is giving us the distance evaluated at 2 minus that distance evaluated at the starting point, because we are considering on the entire journey, not at point 2, the entire journey. So this is, if we evaluate S at 2, what is S of 2? That is negative 16, 2 raised to power 2 plus 64. That is 0. So this is 0. So that is 0. Shit. Okay, my pen disappeared. Why is that? Oh my gosh. Okay. I need to. Oh, it's back. Interesting. So 0 minus S of 0. So if I do the same thing, put 0 here, so that is everything here is 0. So I have 64. So that is 64 divided by 2. So that is negative 32 feet per seconds. So you can see the average velocity, the average speed on the entire journey is actually 32 feet per second. This is telling you that it is dropping. The particle is dropping. But at the instant when it is 2 seconds, then you can see it is actually negative 64 feet per second. So you can see the comparison between an instant of time and the average on the entire interval of time. Okay, let us also compare or interpret velocity and acceleration. A particle moves along a coordinate axis in the positive direction to the right. Its position at time t is given by this. So the position function is given as t raised to power 3 minus 4t plus 2. We want to find v of 1, a of 1. So let us quickly find v of t first. We need to find v of t. So which is 3t squared minus 4. So v of 1 is 3 times 1 squared minus 4. That gives us negative 1. Well, that is less than 0. A of t is 6t. That is, I need to take the derivative of the velocity. That is, take the derivative of velocity, so which is 6t. So at that instant of time, what is happening? 6 times 1. So that is 6. Now let us answer this question. A, is the particle moving from left to right or from right to left at time t equals 1? So look at it. At time t equals to 1, our velocity is negative. So we say the particle is moving from right to left at t equals 1. How do I know? Since v at 1 is negative, moving backward, right to left. Okay, B, is the particle speeding up or slowing down at t equals to 1? Well, look at this. Acceleration is positive. Velocity is negative. Opposite sign. They have opposing signs. So we can say since the velocity at 1 is negative and the acceleration at 1 is positive. Then what do we have? We say the particle is slowing down. Don't forget, like I explained earlier, if they have the same sign, it means the particle is speeding up. That is that. Um, Another example. Another example. Maybe I should take this. Uh, let's see. Let me solve this. I believe this is bigger. Let me solve this as my example 2. And I will give you that as right. Okay, so I will turn this to you try it. So let me solve the bigger one. Okay, so I call this example. Example 2, I believe. All right. So a car is moving along a straight road. Its position is its position in meters at time t seconds is given by that function, and we are told time is positive or equal to 0. Okay, the first question is we should find the acceleration, the velocity, the acceleration, and jerk of the car. Let us find that. Velocity, remember, velocity is the derivative of distance, position function. So which is 4t raised to power 3 minus 24t raised to power 2 plus 36t. Acceleration. Acceleration, which depends on time, is when we take the derivative of velocity. Rate of change of velocity is acceleration. So which is 12t squared minus 48t plus 36. And jerk, remember, jerk is the rate of change of acceleration. So which is 24t minus 48. So that is that. Next question. At what times is the car at rest? Meaning, at what time is it not moving? No speed. The speed is 0. That is, the velocity is 0 at that point. So set v of t to 0. This is the question we are asking. This is the question we are asking. We are asking, when is v of t equal to 0? So this is our v of t. So we set it to 0. That is 4t raised to power 3 minus 24t squared plus 36t equal to 0. So to do this, we can factor 4t. So I have t squared minus 6t plus 9 equals to 0. So this is 4t. I can further factorize this. This is minus 3t minus 3 equals to 0. And that implies that t equals to 0, because 4t equals to 0 will give you t equals to 0. And t equals to 3 is the same. So t equals to 3. So that implies that our time will be 0 second. Unit is very important. And t is 3 seconds. So that is when we are at rest, momentarily at rest. Okay. Oh, All right. Next question. On what interval of time is the car moving forward and moving backward? Want to know interval of time? Well, it's as if you're going to a supermarket or you are driving to school or whatever, and someone is asking if you drive from your home to school, maybe that is taking you 10 minutes, and it's saying, on what interval of time are you moving forward or you are moving backward? We can ask that question. So how do we answer that? Um what explains to us when our car is moving forward and moving back? That is velocity, right? The signs there, right? So what I will do is to study the velocity. So I will do what is called a sign test for velocity. And it is good I know when I'm momentarily at rest at 0 and at 3. I'm at rest at those 2 points. So the question is, what is happening within 0 to 3 and from 3 and beyond, from 3 and beyond. So to do that, I can just pick a point here, let's say 1, and I can pick a point here, let's say 4, and test those intervals of time. So I will find V of 1 and a V of 4. So V of 1, let's go back. What is our velocity function? This is our velocity function. So that is, let me write V of t equals to 4 t raised to power 3 minus 24 t squared plus 36 t. Meaning that V of 1, I can now find V of 1. V of 1 is 4 times 1 raised to power 3 minus 24 times 1 raised to power 2 plus 36 times 1. So which is 4 minus 24, that is something. 4 minus 24, that is minus 20. Minus 20 plus 36, that is 16. So whatever I get there is going to be positive. That is the most important thing. My answer is going to be positive there. What of V of 4? V of 4, that is 4 times 4 raised to power 3 minus 24 times 4 raised to power 2 plus 36 times 4. Okay, 4 raised to power 3, that is 4 times 4, 16 times 4, 64 times 4. 64 times 4, 6, 1, 24, 25. So that is 256. Then the next one, 4 raised to power 2, that is 16. 16 times 24. That is 4, 2, 4, 6, 2, 2, 1, 3. So that is 4, 8, 3. So minus 384 plus 36 times 4, that is 72 times 2, that is 144. If I add these to these and subtract this, so it means my answer is going to be positive. So my answer is positive. So we have it that on this interval, it is positive. On this interval, it is positive. So the question, on what time intervals is the car moving forward? Moving backward. In fact, we are not moving backward at all. Velocity is not negative anywhere. So we say the car is moving forward on 0 to 3. It is moving forward. I use open because at 3, it is at rest. So I'm not including that 0.3. And also, that's not the only place where it is moving forward, also moving forward from 3 to infinity. So that is that. Um, Another question. When is the car speeding up and slowing down? Now, in this case, you remember, how do we check speeding up, slowing down? I want to know my acceleration, the sign for acceleration. The first thing I need to do is to know when I am not accelerating at all. So I need to first ask, when is my acceleration 0? That is when I am not accelerating at all. I'm not accelerating, I'm not decelerating. It is 0. I'm cruising. So I want to know that time. It is important because since I need interval. So what is our acceleration function? This 12t squared. Uh, that implies we want to set 12t squared minus 48t minus 48t plus 36. We are asking, when is it 0? I can divide through here by 12. So t plus 3 equals to 0. I can solve this. T 3 times 1. So minus 3. T minus 1 equals to 0. It turns out that I am cruising when t is at 3 seconds and when t is at 1 second. I'm cruising at those 2 points 2 times, if you can picture it that way. Okay, now let us answer our question. We want to know, when is the car speeding up and slowing down? So let us see. Now again, we do sign test for acceleration. Okay, now we know when it is not accelerating at all. That is at 1 and at 3. This is 0, then keeps going. So again, what do we do to test? Pick points. So here I can pick 1/2, here I can pick 2, I can pick 4. So I will test for my acceleration in those at those points. So a of half, 1/2 is, I will test a of 2, what is happening in that interval, a of 4, what is happening. So a of half, I just need to use my function for a. So that is 12 times 1/2 squared minus 48 times 1/2 plus 36 equals to 1/2 raised to power 2. That is 1/4. So what is 1/4 of 12? That is 3 minus 48 times half. That is 24 plus 36. What matters here is the sign. So I have 39 minus 24. So here is positive. So it means on this domain, 0 to 1, it is positive. A is positive there. So I go to 2. So that is 12 times 2 squared minus 48 times 2 plus 36. So that is 4 times 12. That is 48 minus 96. In fact, that is minus 48 plus 36. That will be less than 0. So here is negative. So if a of 4, that is 12 times 4 squared minus 48 times 4 plus 36 equals to, that is 16 times 12. 16 times 12, 2, 1, 3, 6, 1, 2, 9, 1. 192 minus 48 times 4, that is 96. 96 in two places. I believe 192 as well, plus 36. So in fact, that is positive. So plus 36. So that is positive. So here is positive. Now we can compare this V of t with A of t now. Now, from look at how we break it down. From 0 to 1, from 0 to 1, acceleration is positive. Now, the velocity from 0 to 1, here is 0 to 3, but I have 1 within that interval. So it is positive, meaning they are the same direction. So I can say the car is speeding, speeding up on 0 to 1. I'm sure of that. Let us go. From 1 to 3, it is negative. From 1 to 3 here, it is positive. So I can say the car, the car is slowing down because they have different opposing signs on 1 to 3. Okay. So from 3 and beyond for acceleration, it is positive. From 3 and beyond for velocity, it is positive. Same sign. So that means it is speeding up from 3 and beyond. So done. We have answered the question of when um, the car is speeding up and slowing down. We didn't do much here. We only ask, let us first look for when the car is cruising. That is when acceleration is 0. So we established that it is at 1 and 3. Then we just did sign tests to know within those three intervals, pick points, and you test. Then we tested, then we compare it to velocity. Remember, to know if it is speeding up or slowing down, you need to check the signs on the same domain. What is happening with A and what is happening with V at that point in time. Okay, interpret the sign of the jerk at t equals to 1 and t equals to 4. What is our jerk function? Our jerk function is 24t minus 48. So jerk, j of t is 24t minus 48. So j of 1 is 24 times 1 minus 48. So which is negative, that is minus 24. J of 4 is 24 times 4 minus 48. That is 96 minus 48, so which is 48. So that is positive. So interpret it. So what interpretation can we give this? Well, at time t equals 1, the car, or let's say the driver, since it is negative, so we can say the driver because jerk is negative, so you can claim that the driver suddenly applies brake. And at t equals to 4, we can claim that the driver suddenly sped up. Describe the entire motion of the car from t equals to 0 to 5. Oh, this is similar to saying, tell the story, right? That's the story. Um, that is from 0 to 5. Let us see. It's just similar to asking you what happens from the beginning. So it's just saying this is simple. Let us see. The car starts from rest. That is when t is 0, starts from rest. And you see the car moves forward because this is positive. This is positive here from 0 to 3. So you can say the car moves forward from 0 to, excuse me, from 0 to 3 and momentarily stop at 3 seconds and then start moving forward again. But we know that some things happen in between. So you can add. So from 0 to 1 second, you can see that we have a story here. The car is speeding up. The car is speeding up from 0 to 1 and slowing down from 1 to 3 seconds, and now speeding up from 3 and above. So that is what this question is asking you, from 3 to 5, because there is a limit there. So that is what this part is asking you to do. So I hope this example helps you to understand what happens when you drive. So when you drive, you can make sense of what is happening with calculus. Okay. So you can pause this video and answer this try. You have two there, so I will call this one, call this two. So do that. All right. Now next up, let us study amount of change. Well, this is similar to what you've seen before in this class. So suppose I have a function like this, and I say this is A plus H, and I ask you to find the net change. So here is f of A, here is f of A plus H. So that is here, right? So that is changing y values. That is just what the problem is. So the amount of change of f of x over that interval can be, you can say that is f of a plus h minus f of a. Okay. What is the average rate of change? Average rate of change. Well, average rate of change is f of a plus h minus, that is that net change, divided by the distance from ear to ear, which is h. So divided by h. Okay, just repeating what we have done. Instantaneous rate of change. Well, instantaneous rate of change of f of x. Remember, it is given as this. So which is now the limit as that change, h, getting closer and closer and closer to 0, but never equal to 0, saying the limit as h goes to 0 of our expression in the bullet above. So that is the instantaneous rate of change. I've said this exactly when I was trying to solve a problem here today. Okay, now, if we compare what we have, so let us look at this fine graph. So this is just at point A, here at point A plus H. Now, look at something. Our claim is that we can do something. We can say, if we pick, look at what I'm going to do. If we pick our H to be very, very small, 0.0000000000001, very small, I can claim that I can write this as f prime of x is approximately equal to f of a plus h minus f of a divided by h. Remember, this is the amount when you add that h, we can look for it. And I will tell you why it is useful. Okay, here I'm saying at A, so let me just use A here. A, A. Okay, so I can say f of A plus h cross multiplying minus f of A is approximately equal to f prime of A times h. And now that amount f of A plus h is approximately equal to f of A, I throw this guy to the other side, plus f prime of A times h. This is a formula we can use to find amount of change. We'll see how it is useful. But before that, look at this. We are saying that, let's say this is point A, this is point A plus h. Remember, tangent line, so the slope of the tangent line. So at this point, that point A. So we're saying that we can use this point to approximate. That's what we are trying to say. So, but we can now see that depending on what our h is, if it is big, then there is going to be some error. There is always error, but we can minimize our error if our h is very small. So you see, suppose my h is somewhere here, then I will be considering a point like this, which is very, very close to this point. And in fact, you don't really see the error. Okay. Let us use the idea to solve this problem. Example. If f at 3 is 2, and the derivative of f at 3 is 5, estimate f of 3.2. Okay, remember, f of 3.2. Can I say it is the same thing as f of 3 plus 0.2? So in that case, I'm saying this is A, I'm saying this is H. And then I can use my formula. F of A plus H is approximately equal to f of A plus the derivative of f at A times H. So in this case, f of 3.2 is approximately equal to f of my A is 3 plus f prime at 3 times our H is 0.2. And I see we were given all those things. So this is equal to f of 3 is 2 plus f prime of 3 is 5. So 5 times 0.2, which is 2 plus 1. That is 5 times 2 over 10, so 1. Sorry, 5 times 2 over 10. Yeah, that is 1. So our answer is 3. So what we're saying is that what we are saying is that so this is so what we are saying is that f of 3.2 is approximately equal to 3. So we were able to find that value, right? Because we know the rate of change. Quickly, we will go into what is the relevance of this. We'll use a real life scenario to see the usefulness of this. So I will just ask you to pause this video and do the same thing we just did there to find f of 10.1. Now, why is this useful? How is this useful? Think about a situation like we can know at every point in time, we know the population of the world, population of the world. Then we also know the rate of change, the rate of change of that population. We can study that. We know the rate of change. So what this idea helps us to do is to help us evaluate when, let's say, we consider our time right now, then we can say what happens in the next 5 years. That is when age is 5. What happens? So it can help us to solve a problem like that. So that is why we um, are using that idea. So if P of T is the population of entities present in population, then the population growth rate is defined as P prime of T. Example, the population of a city is tripling every 5 years. So let's say now it is 5,000. In the next 5 years, then it will be 15,000 because it is tripling. If its current population is 10,000, what will be its approximate population in 2 years from now? 2 years' time from now? Well, that is not easy to find from this because if it is in the next 15 years, then okay, we know what to do. But in the next 2 years, okay, we need to do something. So what if I can find, let's say in the next, the population of a city is tripling every 5 years. If its current population is 10,000, I know the current population. So I can say at time t equals to 0, P of 0 is 10,000. I also know that um, every 5 years, it triples. So meaning I can know P of 5. So which is, in this case, going to be 30,000. So that is when T is 5, right? So with this, I can find rate of change, right? I can find this. So I will call it P prime of 0, right? So which is P of 5 minus P of 0 over 5 minus 0, so which is what is that? 30,000 minus 10,000 divided by 5, and that is 20,000. That is 4,000. 4,000, the population of a city. Okay, so we can say people per year. That is the rate of change, increasing It is positive, so it means it is increasing by 4,000 every year. Now we can talk about in the next 2 years, what happens. So if we just say P of 2 now will be approximately equal to P of 0, what we have now, plus the derivative of P at 0, right, times H. So this is P of 0 is 10,000 plus the derivative, right? So that is 4,000 times 2, because it's moving from 0 to 2, right? So that is 10,000 plus 8,000, and that is 18,000 people. 18,000 people. That is what we have. So you can use the same idea to solve this problem. The current population of a mosquito colony is known to be 3,000. So you can take that to be T at 0, the population is 3,000. Oh, giving a P of 0 is 3,000. Oh, you have been given the derivative at 0 to be 100. Estimate the size of the population in 3 days, where the time is measured in 3 days. So just use this. P of 3 approximately equal to P of 0 plus P prime of 0 times H. In this case, what is our H? Our H is 3, right? So just complete that from there. Now, let us use the same idea to address another real-world situation. And this is in business. This is in business. So, if we represent cost of production of X items using the C of X, then we say marginal costs is this. How so? Let me show you something real quick. Again, we return C prime of X is the limits as H goes to 0, let's say of C of, let's say, X plus H minus C of X divided by H, right? Now, just like we did the other time, if we take our H to be very small, now in this case, because we are producing items, so the least item we can produce is 1. So we can say that, well, that means C prime of X is, so I can say it is approximately equal to C of X plus 1 minus C of X divided by 1, which is this. Now, what does this show us? What does this mean? It means, okay, the cost of producing the next one item. You see, the next one item. So, for example, just bring yourself out of calculus now. If I say, what is the cost of producing the 51st item? All what you need to ask me is, what is the cost of producing 51 items? What is the cost of producing 50 items? Then you subtract it, then you know, okay, that is the cost of producing the next one item. So calculus can also help us to figure that out. And you can see, I just show you this. And now, in that sense, we call these marginal costs. So marginal cost is the derivative of the cost function, which is expressed this way. I hope that makes sense. So similarly, we can talk about marginal revenue. What is revenue? Revenue is the money you generate from the sale of your X items. So let's say your price is represented by P of X and you are selling X items. So your revenue will be X times P of X. So that is revenue, which is the unit price. Sorry, this is the unit price times the number of items sold. Now, we can ask, what is the revenue generated when we sell the next one item? You might ask, why is this important? Why do we care? I will show you a real example to see why we care about this situation, because it helps business owners to make decisions. So we can also talk about marginal revenue, which is also taking the derivative of the revenue function. We can talk about marginal profit, which is the same as taking the derivative of the profit function. Let us apply this new knowledge to real life. Okay. Assume that the number of barbecue dinners that can be sold, X, can be related to the price charged, P, by the equation. So the price, P of X, because price and profits usually, so we use capital P for profit, small p for price. So the price is 9 minus 0.03x. So we are producing, the number of barbecue dinner is between 0 and 300. We cannot produce infinitely many barbecue dinners. Okay. Now, okay, let's go back. Assume that the number of barbecue dinners that can be sold, X, can be related to the price, P, by the equation P of X is this. In this case, the revenue in dollars obtained by selling X barbecue dinner is given by revenue. Remember, how do you calculate revenue? Revenue that you generate is the unit price multiplied by the number of items you're selling. So in this case, that is X times P of X we have given, that is 9 minus 0.03x. So that is 9x minus 0.03x squared. Okay, use marginal revenue function to estimate the revenue obtained from selling the 101st barbecue dinner. What does that mean? Let us go back to what we have here. Remember, marginal revenue will also be written as R prime of X approximately equals to R of X plus 1 minus R of X, right? If we do the same thing we did with cost function. Now look at this. Suppose I'm looking for R of 100. R of 101. So it is the same thing as saying I want to know the marginal revenue, that is the revenue generated when I produce or when I sell the next one item after 100, because it is 100 plus 1. I hope you are with me, right? So in this case, so I'm saying the derivative of R at 100 is giving us R of 100 plus 1 minus R of 100. So that is what we want to find, right? Remember my explanation the other time. If you don't want to use calculus, you only need, okay, what is the revenue generated for 101? That is revenue generated for 101 items minus revenue generated for 100. You subtract, you have the revenue for the 101st item. I hope that makes sense. So calculus can help us to figure that out. So what we need to do is take the derivative of your revenue function. And in this case, that is 9. I'm taking the derivative of this. 9 minus 0.06x. So then the revenue obtained from selling the 101st. So meaning R prime of 100. Please don't make mistake. That is what I write. So that is why I went back to show you that. So R prime of 100 equals to 9 minus 0.06 times 100. And that is 9 minus 0.06 times 100. That is 6. So that is $3. $3. Compare this to the actual revenue obtained from the sale of this dinner. That is, don't use calculus. Just find the way you would do it without calculus. Let us compare our answer. That is, you want to find R of 101. You want to find, so which is, okay, let me do that. R of 101. Then you want to find R of 100 and you subtract, right? So what is R of 101? This is the function for R. So that is 9 times 101 minus 0.03 times 101 squared. So R of 100 as well is 9 times 100 minus 0.03 times 100 squared. So this will give us, oh my gosh, that is 909 minus 101 squared. Wow, that is, we can do that, but just permit me to just use my calculator to do that. So multiply by 0.03. So that is 306.03. So which is 602.97. So here as well, that is 900 minus 100 squared times, that is easy to do anyways. 100 squared times 0.03, so that is 300. So which is 600. So if we subtract, so for the 100 and, oh shit, for the 101st item, the revenue is R of 101 minus, that is the revenue you generated by selling 101 items minus revenue you generated by selling 100. So which is 602.97 minus 600. So this is $2.97. Now, guys, look at our results when we use calculus. When we use calculus, we got $3. When we do the actual revenue, we have 2.97, which we can claim is approximately $3. Now look at how messy this is. Too much work, so complicated. Look at what we just did here. Just took the derivative and just did this. And we're there. So that is the beauty of calculus. I just did that to show you that, oh, truly, calculus can help us to approximate that situation. So instead of going through all of this, we just use calculus. I think we are done with that problem. Yeah. Okay, let me solve this. Let me solve a bigger problem. Let me solve this. I will change this to, again, to example 2, and I will just change this to try it. Try it number 5. Okay, let me take this to, yeah. Okay, now let me solve this one. In general, the profit function. Okay, before I solve this problem, guys, you have seen this situation before. If you've taken Math 141 before, you have actually solved, problem similar to this before, but then you did not have calculus. So you were using the idea of quadratics, vertex, h comma k, right? You've done that, something similar to what we are doing now before. Okay, in general, the profit function is the difference between the revenue generated and the cost of production. That is true. To know the profit, what do you generate? Subtract cost of production there from there, then you have your profit. Okay. So I've told you how to find revenue. Your unit price multiplied by the number of items. For profit, it is the revenue generated minus costs. That is how you find profit. And I also told you the meaning of marginal cost. That is the costs for producing the next one item. Marginal revenue. That is the money generated, the amount generated, the revenue for selling the next one item after that particular uh, point. Okay, we can move on now. Suppose the price, demand, and the cost functions for the production of cordless drills is given respectively by P, that is the price. That price depends on the demand, that is the number of items sold. P of X is 143 minus 0.03x, and the cost of production is given as this, where X is the number of cordless drills that are sold at a price P dollars per drill, and C of X is the cost of producing X cordless drills. Yeah, I've explained all those things. Problem 1. Find the marginal cost. Well, marginal costs, remember, take the derivative of your cost function. So that is, our cost function is given as this. So if I take derivative of that, I have 65. So $65. What does that mean? It means, this is just 65. It means it costs $65 to make additional item, additional one item. Okay, well, that is that. That is that. Just that. Um, find the revenue and marginal revenue functions. Okay, revenue function, R of X is, now we need to be careful with R of X. We don't know R of X, let us find it. R of X is the unit price multiplied by the number of items. So X is the number of cordless drills sold. So X. So that is X times P of X. So which is X times P of X is 143 minus 0.03x. So this is 143x minus 0.03x squared. So that is the revenue function. Marginal revenue function. Remember, for marginal revenue function, we need to take the derivative of the revenue function. So that is 143 minus 0.06x. So that is the function that represents the marginal revenue. Let's keep moving. What is this? Find R of 1,000. That is, now, before I say anything, what does this mean to you? R prime of 1,000. You should be able to understand that. It is the revenue generated for selling 1,001st cordless drill. I hope that makes sense. So meaning we just need to use our revenue, this. We already take the derivative, so 143 minus 0.06 times 1,000. See how easy it is? So that is 143 minus 0.06 times 1,000. That should be 60. 60 minus 143. 73? No, 83. Yes, that is $83. So what does that mean? It means the revenue generated for 1,001st, what's it called? Cordless drill is $83. Okay, that 1,001st is $83. That is the amount generated. Okay, what of R prime of 4,000? 4,000. So we do the same thing, 143 minus 0.06 times 4,000. 143 minus, that is 240. Because 0.06 times 1,000 is 60, so times 4, so that's 240. I hope that is correct. Yeah. Okay, so this would be negative 240 minus 143. So 7, 3, 1, 13, 4, 9. Okay, that is minus $97. Wait, look at this. That means the amount of money generated for 4,001st cordless item is now in the negative. Something is happening. Okay, let us keep moving. Let us keep moving. Find the profit and marginal profit function. So let us find profit function, marginal profit function. So what is profit? Remember, profit is R of X minus C of X. We have computed R of X, which is this, R of X, minus C of X. So that is 143X minus 0.03X squared minus, I will need to be careful with that minus, so I use parentheses. So what is C of X? C of X is 75000 plus 65X. So which is 143X. So I'll call this profit function, capital P, profit function. So 143X minus 0.03X squared minus 75000 minus 65X. I can combine this and this, so that is 143 minus 65. Oh my gosh. Ah, it's been a long day. So 8, 7. There might be some mistakes in my arithmetic. Please forgive me if there is any. 78X minus 0.03X squared minus 75000. So that is the profit function. I will just copy and paste that here. Profit function is 78x 78x minus 0.03x squared. I believe it is minus 75000. Yes, so that is the profit function. Now, marginal profits. So by now you understand what marginal profit means. So marginal profit, that is the derivative of the profit function. So which is 78 minus 0.06x. This becomes 0 when you take derivative. So I have this. Now let us use it. The question here is, we should find P prime of 1000. Again, you understand what that means. That is the profit you are making on the 1001st cordless drill. Okay, so in this case, I just need to use this. So that is 78 minus 0.06 times 1000. So again, that is 78 minus 60, I believe. So that is $18. Oh, what this tells you is that when you produce 1001st, you are still making profit. As a business owner, that is informing you of something. The price you are selling, the number of demands you are having is still making sense for your business, because the profit is still $18 per one after making that 1000 items. So that is still good. Okay, let us check for 4000. So that is the profit you are making for the 4001st cordless drill. So again, 78 minus 4000 times 0.06. So that is 78 minus, that should be 240, I believe. Oh, this is negative. Now you are making profit, negative profit. That means your selling price now is ridiculously low, that you are now losing profit. So this is minus 162 times 0 remain 1, 13, 14. Yeah, 162. So that is negative 162. So meaning by the time you are now producing 4,001, you are not making profit again. You are not making profits. You are really losing. And that explains why when you compute the money you are generating on on selling the next item after 4,000, it is negative. So you can see, in fact, you are losing in profit $162. So you can see how beautiful this is because it will inform business owners. Oh, now, no, we cannot just keep producing. We need to stop. But then the question you might be having now is, when do I stop producing? So we need to study additional concepts to help us get to that. In your pre-calculus one, you learned the concept of vertex. So you want to know when your revenue is maximum, when your revenue is maximum. So we have a concept in calculus as well that will help us determine when your revenue will be maximum or when your profit will be maximum. We have these beautiful things to use. So we will get there. We are not there yet. We will get there. So you can go ahead and now take your time to answer these two problems. So I hope you have fun answering these two problems. Try it number 5 and try it number 6. So I'm going to be stopping this video here and I will see you in my next class. Thank you and bye-bye.